So today I'm going to explain insertion and deletion in a binary tree. At first, binary trees can look kind of confusing because there are so many branches and nodes everywhere, but the actual logic behind them is pretty simple once you break it down. In a binary tree, every node follows one rule. Smaller values go to the left and larger values go to the right. That's basically the whole reason the tree works. So let's start with insertion first because that's the easier one. So imagine we have a tree with 50 at the top. Then maybe 30 is on the left side and 70 is on the right. And let's say we want to insert the number 40. You always start at the top of the tree and compare values as you move down. So first we compare 40 with 50. Since 40 is smaller, we move left. Then we're at 30. This time 40 is bigger than 30, so we move right. And if there's nothing there already, that's where the 40 gets placed. And that's all insertion is. You just keep moving left or right until you find an empty space. The nice thing is that the tree stays organized automatically because every value gets placed based on size. Deletion is where things get a little trickier. There are basically 3 different situations that can happen when removing a node. The first one is easy. That's if the node has no children, meaning it's just sitting there by itself at the end of a branch, you can just delete it, and nothing else really changes. The second is when the node has one child. In that situation, you basically skip over the node you're deleting. The parent connects directly to the child instead, so the tree still stays connected properly. Now the third case is like the annoying one. That's where the node has 2 children. For example, imagine deleting 50 from the tree earlier. You can't just erase it because everything below it depends on that position. So instead, what usually happens is we replace it with another value that keeps the tree in order. Most of the time we use the smallest value from the right side of the tree. So if the next smallest number is 50, we move 60 up into 50's spot. Then we go delete the original 60 node from where it used to be. That way the structure still follows the binary search tree rules after the deletion. The main use for binary search trees is speed. Because the data is organized, you don't need to check every single value one by one like you would in a normal list. At every step you can immediately decide whether to go left or right, which cuts down the amount of searching a lot. That's why operations like searching, insertion, and deletion can all be pretty efficient. Of course, if the tree becomes really uneven, things can slow down. But in general, binary trees are much faster than basic linear searching. So insertion is just finding the correct empty spot, and deletion depends on how many children the node has, and the tree structure is what keeps everything organized and efficient. And that's how insertion and deletion work in a binary search tree.